Think about the sheer variety of diets out there in the animal kingdom. A lion tearing into meat, a horse grinding down tough grasses, a dolphin snapping up slippery fish. Yet, despite these radically different lifestyles, all of these animals share one surprisingly consistent biological trait: off-white teeth. In nature, physical traits are rarely engineered for looks. Evolution selects for survival and function. This chart shows the extreme bite forces animals generate to eat, measured in newtons. A human molar withstands about 700 newtons, but a hyena or crocodile generates several times that amount daily, without their teeth shattering. If nature is optimizing these tools strictly to crush bone and grind food, why does it seem to paint almost all of them the exact same color? This universal white color is merely a physical consequence of the specific minerals nature uses to build its biological blueprint. For vertebrates, that blueprint relies on a specific mineral called hydroxyapatite. It is a crystalline calcium phosphate that makes up roughly 96% of tooth enamel. It is the hardest substance the human body produces. Unlike your skin or your hair, mature enamel contains 0 living cells, no blood vessels, and no biological pigments. In a microscopic cross-section of enamel, incoming visible light rays strike millions of tiny crystalline structures, scattering outward to produce a translucent, white glow. But shifting focus downward, the dentin below is naturally pale yellow. That yellowish tint bleeds right through the translucent enamel. Those perfectly bright, blindingly white smiles you see in Hollywood movies are an optical illusion, usually achieved with bleaching or veneers. Natural, healthy biological teeth are inherently off-white or cream-colored. The white tooth rule exists because for over 400 million years, evolution conserved a highly effective, fracture-resistant material that happens to scatter visible light. But what happens when an animal's lifestyle is so extreme that standard hydroxyapatite isn't strong enough to keep them alive? Take the beaver. Its bright orange front incisors often look to us like a sign of severe disease or terrible hygiene. Actually, it's a chemical adaptation. Evolution infused their enamel directly with high concentrations of iron. This creates a reinforced, continuously growing material that resists heavy wear from daily woodcutting. Other animals, like elephants and narwhals, bypass the standard enamel rule entirely. Their massive tusks appear as a distinct yellowish ivory. That unique color happens because their tusks are actually modified incisors made almost entirely of exposed dentin, stripping away the white, light-scattering enamel altogether. Then there are sharks. Their rows of pale, white-looking teeth seem to follow the standard biological rule, but they are actually an evolutionary illusion. Sharks lack true enamel entirely. Instead, they produce a material called enameloid. It forms through a completely different biological process, using different connective tissues, yet it independently evolved to achieve the exact same mechanical strength and light scattering effect. Nature only abandons the standard white blueprint when a specific extreme survival niche demands a structural or chemical upgrade. These animal adaptations are a library of solved engineering problems. Look at this side-by-side diagram. On the left, we have the microscopic iron-infused layers of a beaver tooth, and on the right, the metallic layers of an industrial drill bit. Material scientists are directly studying that biological matrix to figure out how to manufacture tougher, self-sharpening cutting tools. Back on the human side, medical researchers are heavily analyzing the exact crystalline structure of hydroxyapatite, trying to figure out how to artificially grow synthetic enamel in laboratories. There is a biological urgency to this research. Unlike your bones, which can heal from a break, your tooth enamel cannot repair itself. The specific cells responsible for building it disappear permanently the moment a tooth erupts from your gums. The ultimate goal of this regenerative dentistry is to move completely past artificial fillings and instead use bio-inspired materials to actually heal and regrow damaged human teeth. The next time you see a dog panting or catch your own reflection in the mirror, you see a 400-million-year-old achievement in material science, an evolutionary solution that now provides the blueprint for the next generation of human tools.